Alright, everyone, let me know in the chat if you're back. Never left. Okay, awesome, good. Let's go on to this next stage, guys. So, a part of me wanted to skip this, but the reason why I didn't is because I have seen a fair share of 6 markers on this question, and a lot of people miss out the details. Why am I covering the syllabus beginning to end? Because, guys, the marks are in the details. Okay, the marks are in the details. You might know a process, but if you don't know how to describe it properly with the right words, you're good as the guy who's getting a grade 2. Okay, sorry to put it like that, but you need to know the words, you need to know the details. So if you're thinking of enzymes, yes, you got to remember kinetic energy. You have to remember successful collisions. Successful collisions is a topic that comes up in chemistry. Do you guys remember that? Yeah, successful collisions is a topic that comes up in chemistry. That's a chemistry topic where you talk about atoms. Do you need to get this drawn out? Just a sketch of the shape, and physics, exactly, and physics. So total internal energy, all that kind of stuff. So just the shape is required, but we just got to understand the shape. So as soon as temperature increases, you're getting more successful collisions because you have more. Does everyone know what I mean by it when I write this? Kinetic energy. Okay, so enzymes and substrates have more kinetic energy, and therefore more are turned into a product. So increased chances. We're gonna do that when we hit November. That's when we're gonna start doing the papers and learning the 6 markers as formulaic responses. Can you see that temperature is rising along with the rate of enzyme? Do you mean rate of enzyme activities? The other way around. Enzyme activity rises with temperature. Awesome. Okay, so here you have rate of enzyme activity. Here you have temperature. I'm pretty sure you all know that there is a required practical that is linked to this. Okay, so anyway, it rises up, and then it hits the optimum temperature. After it gets optimum temperature, the enzyme activity drops. And why does it drop? Because at this stage, the enzyme has been denatured. It's lost its shape and it can't work anymore. When it's at a lower temperature, so when it's cold, there is no kinetic energy and therefore no movement. And if there's no movement, are the substrates going to form enzyme substrate complexes? No, they're not, because there's no movement. So at low temperatures, there's low enzyme activity because there's low kinetic energy. And then as it rises, you got more kinetic energy, so therefore more successful collisions. When you get to the high temperature, it's different. It's not the same. These are not the same, okay? So this and this is not the same. Here it's denatured, so it's irreversible. Whereas here, you just need to increase temp. Does that make sense? Do they denature at cold? No, they just denature at high temperatures. I wrote just natured. So they just denature at high temperatures. Okay, and then at low temperatures, they just don't bind, but there's no kinetic energy. So yeah, if you have more successful collisions, you're going to have more enzyme substrate complexes because they're going to combine at a faster rate. Right, okay. Also, we're getting there. We're getting there. Everyone okay with that diagram? We're moving on. Okay. pH is the one where everyone gets a little bit of the details confused. So let's jump onto... guys, let me know if you're there in the chat. Harris, let me know if you're there. Zia, let me know if you're there. Rahel, let me know if you're there. Awesome. Okay, good. I'm not here. Harris, if your keyboard is not working and then you can't chat in the chat box because I notice your name's not showing up, can you leave the lesson and join back? It should work after that because I notice you can't respond. Okay, let's begin. We're going on to pH, people. So, the effect of pH. The optimum pH for most enzymes is 7. So, the equivalent will be 37 degrees, right, in terms of temperature. But some are produced in acidic conditions such as the stomach. They have lower pH, pH 2, and some are produced in alkali conditions such as duodenum. Where is the duodenum? Between what two structures? The duodenum, this thing here. Anyone remember? I mentioned it. I don't pronounce it very well though. Where is it? It's between the gallbladder and the bile duct. No, sorry, bile duct and stomach. Sorry, my mistake. Bile duct and stomach. Yeah, because where is the thank you, George. So remember the bile is joining. Wait, hold on. I'm getting mistaken myself. It's between the. No, hold on. The bile also joins in the small intestine. It's between the gallbladder and the bile duct for now. For now. I need to confirm that. Anyways, if the pH is too high or too low, the bonds that hold amino acid chains that make up the protein are destroyed. No, you don't. Don't worry too much. So when the pH is too high or too low, denaturing takes place. This will change the shape of the active site. So the substrate can no longer fit into it, reducing the reactivity. So pH does what? Very, very similar to temperature. What does it do? It changes the both of them. It changes the active site. They both cause denaturing. Can an enzyme renature? Not possible. Moving too far away from the optimum pH will cause the enzyme to denature and activity will stop. Thank you, Ayman. Right, okay. Are we okay with that? So it has a very similar effect. If all your enzymes denature, you'll have to wait a long time till they all reproduce. Because your enzymes your cells will have to get their ribosomes working, and the ribosomes will make you new ones. Is the graph different for pH? Reduced activity, as in they won't be doing their job. It's similar. It's not exactly the same. Because with temperature it has a peak and then it drops. Whereas with this, it drops gradually. So at pH that's extreme, which is furthest from the optimum, so it's not doing any work here. And then it slowly increases. Okay, and says remember this depends on where the enzyme works in the body. Then that's at the optimum temperature, and then it slows down. So as the pH changes, the shape changes. As the shape changes, it stops doing its job. Exactly, yes. They denature slowly at a lower. They denature at a low pH as well. So it's a bit symmetrical. Whereas with temperature, low temperature, is the enzyme denatured? The answer is no. We're going to end this lesson with the required practical. Is everyone ready? Just a quick one, yeah? How do we know that you are crossing all your T's and dotting all your I's when it comes to revision? Especially with science. That's my question in the chat before I load this up. Sorry, what's that? Before you get past papers, before you get to quizzes, how do you make sure you're dotting all your I's and crossing all your T's? Oh my days, really? Very good. I want to see if anyone says the same thing. Of course, making notes on every single thing is true. So guys, the specification. Where can I get the specification? The spec is literally a word by word list of every single thing you need to learn. The specification, well done, can be found on the AQA website. So please make sure you're downloading the right one. If you do triple, look for the triple. If you do combined, look for the combined. Let's move on. So let's look at the enzyme required practical. Does everyone remember the color food test? Did I say the color food test? I meant to say the food color test. Okay, so what's the aim? And do you need to memorize these? Absolutely. To investigate the effect of pH on the rate of reaction. Now, let me just ask you guys a question, yeah? That's the one, Adam, yes. So investigate the effect of pH on the rate of reaction. If the pH is too low, what does that do to the enzyme? Good. If the temperature is too low, the enzyme gets denatured. If the enzyme gets denatured, will this conversion take place? Very good. The conversion, the breakdown does not take place. So therefore, am I going to see a color change of dark blue to this orange color? No. So as I said, I meant low pH, not temperature. pH. This is about pH. So at low pH, the enzyme does denature, but at low temperature it doesn't. But is the enzyme going to do its job even at low temperature? Will it do its job? No, it will not. It will not do its job. So therefore, this is a very good indication. This is a very good test, a very good indicator to see if the enzyme is doing its job. Okay, so use the enzyme amylase to break down starch at a range of pH levels. So we want a range of pH levels. Using iodine solution as an indicator for the reaction occurring. Using a continuous sampling technique. What does that mean? Anyone know what that means? Continuous sampling technique. Anyone know what that means? Well done, guys. Some of us are really clued in. It means to take readings at regular intervals. So it could be time intervals, it could be pH intervals, it could be on a spotting tile, it could be using a clock. That's what a continuous sampling technique is. So at regular intervals. Yes, but yeah, this is just the details. So regular intervals, so this could be using a spotting tile, which we'll look at in a second, or a stopwatch. Amylase is an enzyme that digests starch into maltose. Starch can be tested for easily using the iodine solution. Okay, so amylase is the smaller version of the molecule, and starch, of course, is the longer version of the molecule. We're moving on, people. We're going to look at the method. Does everyone here know what a spotting tile is? If you've done this experiment before. You don't need to write it down, you just need to know it really. Just know it well. Do you know this? Are you okay with this? Are you familiar with this information? The reason I wanted to define this phrase, yeah? Guys, have you ever gone to an exam and thought, yo, I've never learnt this before and this is annoying because I've revised and these are words I've never seen? It's all the problem is the devils are always in the detail. It's always these annoying words that we just brush past in the revision guide, and then they're the ones that come to haunt us in the exam. So that's why sometimes I go into these definitions just making sure you know it, because it could come up and then we'll freak out when we see it in the actual exam. So I think we can all empathize with the pain. Yes, that's right, man. It is that thing. Right, okay, so let's have a look. So method, place single drops of iodine solution in rows on the tile. Label a test tube with pH to be tested. Yes, it's got these little dimples in them. Apparently it's the same questions every year, but they just change the wordings. That is absolutely fact. Absolutely fact. Right, okay. So place drops of iodine solution in rows on the tile. Label a test tube with the pH to be tested. So this is the spotting tile. Right, they all have iodine added to them. Use the syringe to place 2 centimeters cubed of amylase in the test tube. So guys, listen to what's happening, yeah? Because this is a bit difficult to do online where you don't have the actual apparatus with you. So here you have your test tube, right? And in your test tube, you've got your amylase solution, okay? And then you've got the pH you're investigating. And then you have a starch solution. So you're going to add amylase and the buffer to a test tube mix, then add starch solution and start the stopwatch. Okay, so essentially you've added this to this and then you've started the stopwatch. Okay, so add 1 centimeter cubed of pH buffer to the test tube using a syringe. Use another test tube to add 2 centimeters of starch solution and amylase, start stopwatch. After 10 seconds, use a pipette to place 1 drop of mixture of on the first drop of iodine, which should turn black blue. So let me ask you guys a question, yeah? Everyone knows what a pipette is? So the pipette goes in here. Okay, we take a drop. And this is already mixed, by the way, so this is already in here now. And then you're going to transfer that to the spotting tile. 1 little blob. Okay. After 10 seconds, use a pipette to place 1 drop. Now, why will this turn black blue after 10 seconds? I want everyone to answer this so I know that you know what I'm talking about. Why after 10 seconds will it turn black blue? Like, why won't it turn orange? Because the reaction's taken place or it hasn't taken place. Has the enzyme had a chance to do its job yet? Has the enzyme had a chance to do its job yet? The reason it's gone blue is because the enzyme hasn't done its job yet. Wait, what? Starch turns to what, guys? Starch turns to maltose. This is black blue. This is orangish. So if it's black blue, has it done its job yet? Has it broken it down? Does that make sense? Awesome. Getting a couple of realizations in the chat. Right. Okay, so back to the spotting towel. You wait another 10 seconds and place another drop. Okay? Right? So you're going to wait another 10 seconds or you can do another drop. So this is what continuous sampling is. This is after 10 seconds. This is after 20 seconds. and you keep doing it. You keep doing it every 10 seconds. This is a 2-man experiment, by the way, yeah? One guy's on the stopwatch, one guy's on pipette duty. So this is every 10 seconds. This is 10 seconds, this is 20 seconds, 30 seconds, 40 seconds, okay? Right. You repeat it until the iodine solution turns orange. Repeat the experiment at different pHs, the less time the iodine takes. Now, guys, this is the key. You guys following? This is the key. If you understand these required practicals well, yeah, you know those 6 markers, you're going to be so happy to see them. Experiment 6 markers are the best, guys. They are the best because just recalling an experiment. Okay, enough with the hyperbole from myself. Let me get back to the board, but I've blocked my pen. Okay, here we are. So repeat the experiment at different pHs. The less time the iodine solution takes place, the quicker the starch is being digested. Does that make sense? So this was at pH 7. So you'll have another one, pH 6. You'll have another one, pH 8, pH 9, okay, pH 4. So how many of these tiles are you going to be left with by the end of the experiment? If you answer this question correctly, it means you understood the experiment. How many of these tiles will you have at the end of your investigation? You will have multiple tiles. You'll have 1 tile for pH 4, 1 for pH 5, 1 for pH 6, 1 for pH 7, 1 for pH 8, and 1 for pH 9. Whatever you are investigating. Thank you, Josh. It will definitely do that, Tarek. Definitely. In fact, they'll give you a situation. They'll say, Tom is conducting an experiment, blah, 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 blah. Design an investigation. You must have heard that phrase before. Josh, man, come on, man. You're in year 11. That can't be funny anymore. Actually, to be honest with you, still trending. Right, guys, who wants me to explain this experiment again? Who wants me to explain this experiment again? Because the range of answers I'm getting is like... Okay, awesome. Okay. We're going to do this again. We're going to lock in. We've got 13 minutes. You know, everyone sleeps on required practicals. Even sometimes the nerds at school, they forget to go through them. And when they forget to go through them, they lose marks. So let's not be amongst that crowd. Right. So, in this experiment, you are investigating pH. So what is my IV? What is my IV? Very good. So my independent variable is pH. So I'm going to investigate pH. Let's say, for example, let's be realistic. So pH 5, pH 6, pH 7, pH 8. And one more pH. Wow, that's the second person. 9. Okay. Is everyone understanding this, yeah? So this is my choice. I've chosen to do this. So I want to investigate these different pHs. Should I expect enzyme activity to differ amongst these pHs? Should I expect pH activity to differ amongst these pHs? Of course, right? I should expect less metabolism here. I should expect more metabolism here. And at 9, what should I expect? Again, good. Less metabolism here. Remember the graph, guys? Metabolism. Okay, remember the graph? The graph was like that. Yes, exactly, Tarek. Yeah, that was the graph, right? So this is here, and this is here, right? So I got to investigate these things. So I need to design an investigation. Now I know, okay, how do I know an enzyme is working? I know an enzyme is working through the use of iodine. Iodine tells me when big molecule turns into small molecule. Because the big molecule, which is starch, will stay blue. And the small molecule, which is glucose, will go orange. Is that understood? Are we all on the same page right now? So how do I know if the reaction is taking place? I have a big molecule, and the big molecule will convert to a small molecule, and it will be from blue to orange. So if let me just quickly check, guys, in the chat. If the enzyme is not working, what color will it be? Correct, Yasma. Yeah, to your question. Awesome. Okay, I can see we're awake. So if the enzyme is not working, this conversion does not happen. So it stays blue. If the enzyme is working, then it goes orange. So not working, and working. Okay, so does this enzyme change take time? Does this enzyme change take time? So does this process take time? The answer is yes, it does. Okay, so would it be fair for me to say the faster something works, that means it's optimum, and the slower the change, it means enzyme activity is low? Is that fair? So what I said was, is it fair to say if enzyme activity is optimum, it will happen faster, and if enzyme activity is low, it will happen slower? Is that fair? Thank you, Nathan. Thank you, Adam. Like low, like for example, enzyme activity is not doing its job, so therefore it's staying on the blue side for longer. If it stays on the blue side for longer, that means it's slow activity. If it stays on the blue side for not very long and it goes orange very quick, that means very high. So this is a very time dependent, right? Very time dependent. Okay, now let's get into our investigation. So we are going to have a spotting tile. Guys, I will be finished after this, yeah? So not too long. So here we go. Here we have our experiment. So guys, the first thing I'm going to do, can I go back? Yes, I can. What's the first thing I'm going to do, people? I'm going to get a spotting tile. What am I going to drop into all of the dots? What am I going to drop into all of the dots of the spotting tile? So a spotting tile is like a tile like this, and it has little dimples in them like this. Yo, the artistry is amazing. So what does the spotting tile have? The spotting tile just has these little crevices where I can put liquid into it. And what liquid goes into there? Iodine, 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 iodine. They all have iodine. You get the idea, guys? That's how I set up my experiment. I have a spotting tile. Adam, man, don't do this to me. They all have a drop of iodine. They all have a drop of iodine. Everyone okay with that? Now, remember, what's the purpose of iodine? Iodine, if blue, means enzyme is dead. And if orange, means enzyme is working. Okay. There's a few tiles, yeah. So we're only using one tile at the moment because we're only investigating pH 7. Okay. It could also be the reaction hasn't happened yet. Correct. Okay. So pH, this tile is only for what? pH 7. Everyone understanding that? This tile is just for pH 7. Okay. I hope this is making sense. This tile is only for pH 7. So what happens is I have my pH. I have my enzyme in question. I'm just giving an example. You can have pH 6, 7, 8, 9, whatever you want. Okay. So here's my pH. Man, you did it. You did it to me. Right. Enzyme. And then what am I putting into this test tube? I'm putting the thing that this enzyme needs to break down. Are we understood? Okay. Once that is done, the stopwatch starts. Why do I start it straight away? Can everyone in the chat tell me? Why do I start it straight away? As soon as I pour it in, the person clicks the stopwatch. Because what is happening straight away? What work is happening straight away? True, accuracy, true. What else? The enzyme will start metabolizing. That's why. As soon as we pour it in, the enzyme starts metabolizing. That's why. Okay? So, we look what happens at 10 seconds. We look what happens at 20 seconds. We look at what happens at 30 seconds. We look at what happens at 40 seconds. At 50, at 60, at 70, at 80. Are you guys getting the point? Yeah? We're investigating what is happening at every time. Okay? Now, the enzyme has only had 10 seconds to work. So it'll be about blue here, lighter blue, less blue, turning orange, blah, 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 blah. Okay? Right. If the enzyme has worked really well, which one would be orange? Ones that are further, that have the longer time, or the earlier one? Well done, Nathan. Very eloquent. So which one will have, if the enzyme has worked worked well, will it be the earlier tile or the later tile? So if it goes blue here, that means enzyme has worked well. So earlier tile, enzyme worked well. Later tile, enzyme is slow. And that means pH has, that's okay. pH is denaturing the enzyme. Okay? Okay, so we just did this for pH 7. So what do we need to do now? Everyone in the chat, what do we need to do? What do we need to do now? Correct. We need to repeat the whole investigation for what? We need to repeat the whole investigation for another pH. Okay? And we want to see how quick does it turn orange. Do you get it? So you can see here, after the stopwatch, there you go, right? So at pH 7, it turned orange on the 5th tile. At pH 5, it turned orange on the 8th tile. At pH 9, it turned orange on the 8th tile. Wait, did I just say 8th twice? For pH 5, it turned orange on the 7th tile, 8th tile. And at pH 14, it didn't even metabolize. What does that say about the enzyme? What does that say about the enzyme? It fully did not work. It's fully dead. No, not even a slow reaction. It didn't even get to do its job. All the reaction is still starch. Does that make sense? So at pH 5, the enzyme worked fairly well. At pH 9, it started to slow down. pH 14, completely dead. pH 7, we can say that was the optimum. Guys, let me know in the chat if this makes sense. Let me know in the chat if this makes sense. And guys, if you know this well, the next time you see a 6 marker on this, I'm telling you, you're going to be like, yo, I need this question. Because it's 6 marks, right? Just going to wait for a response from everyone. One second, guys. Okay, what would a 6 marker be? Literally, Tom is investigating the pH of this, or you could say, for example, a new company has invented a bread. They want to see the effect of pH on this thing. Design an experiment where Tom can investigate the power of pH on this new food. That's it. And then you're going to go in and design it. And don't worry, we're going to look at exam paper questions on this. Okay? Thank you, Isha. Thank you very much. Does that make sense, yeah? So we are going to look at exam paper questions on this, but it's always a design. Who's seen design investigation before? Who's seen that phrase, design and investigation? It always comes up. And it could be for any of the required practicals. Too many times. Exactly. Too many times. I would say you get 1 at least in every paper. Actually, that's a bit too much. Maybe 5 out of the 6 papers. 5 or 4 out of the 6 papers. Oh man, yeah, I'm going to get into that one day, but not right now. You always ask me that question. It's so jokes. Right, okay. So where was I? I want to talk to you about something really quick, yeah, before we finish up, yeah? Before we finish up, I want to get into something real quick. Guys, right now, yeah? Right now, all you students are in 2 groups, okay? Are you listening? All of you students are fall into 2 categories, yeah? Those, right? It's not even about intelligence, it really isn't. This refers to those who are locking in at the moment, yeah? Who's revising right now? Like, who's putting in genuine revision time right now? Be honest with yourself. Be actually honest with yourself. It is September, it is year 11. I know, you know, some of us are maybe not taking it as serious just yet. But who has started, who's making a conscious effort? Okay. We all know our own abilities, right? So, finding it hard to lock in. You know, I appreciate that. I understand that. Well, that's where I come in, right? All students fall into one of these 2 categories, right? Students who are causing the grade boundaries to go down, and those who will benefit from lowered grade boundaries. Are you guys hearing this? Now, whilst we very much like these people, we don't want to be them. Do you guys hear this? As much as these people are doing really good community work, we do not want to be them. We want to be these guys. Okay? So remember, there are people out there right now that are revising like the real exam is next week. And there are some people who are absolutely chilling, doom scrolling, wasting time on whatever garbage and not locking in. Okay? Are you guys hearing what I'm saying? Yeah? So try your best to lock in. Honestly, try your best. I'm covering the whole content from beginning to end, right? So my lessons, yes, they might get a bit monotonous. They might get a little bit boring. But trust me, I'm trying to have your back, people. We're covering every single thing. Do combine and triple have different grade boundaries? Yes, they do. Did you guys hear what I said, yeah? So please try your best if you can. Who's struggling to get started? Who's struggling to get started? Okay, good. At least you guys are being honest with yourself. You're being real with yourself. Yeah. But really try your hardest, yeah, to lock in. Let's start putting in the hours now. No, you know what? It is everyone's hamartia. Procrastination is everyone's. If everyone's fatal flaw, everyone's damnation, right? But let's try our best. Make a conscious effort. You're not gonna get it perfect straight away, but we are at that stage now where you can actually make a genuine difference at this point. Some of us have exams coming up that's going to decide which exam tier we're going to be in, which is very stressful. Okay, some of us don't have that. Fair enough. You should be locking in anyway. But for those who got exams coming up that's going to decide the exam tier, you know, you really got to try your best. You got to try your hardest. So, do you guys remember when I said specification? Do you guys remember when I said specification? Get that specification, have it downloaded, have it on your phone, flick through it periodically. Like, ask yourself, I haven't learnt that, or I have learnt this, I haven't learnt this, I haven't learnt this, or whatever it is. Keep tabs on on yourself. Okay, so like I said, guys, you're gonna fall into two groups: either those who are causing the grade boundaries to go down, and those who will benefit from the lowered grade boundaries. You decide, guys. That brings us to the end of the lesson. I'm sorry today wasn't as efficient as possible. I'm so unwell, guys. Hopefully I'll be back on point later at some point. But yeah, I will get to that, Tarek. I will definitely get to that. Should be able to do this. That means you need to be able to do this, man. Yeah. Thank you, Nathan. Guys, enjoy the rest of your evening, people. I hope this helped. Let me know in the chat if you learned something new today. I guess that's always my main concern. Are you learning something new? Are you revising something? Are you embedding some information that you was quite loose in your mind? Is it solidified now? Let me know. Thank you, Ali. Thank you, Nathan. Thank you very much. How are we meant to know what to do? Man, yeah, it's everything on that list. Thank you, Sia. Thank you, Yasma. Thank you, Josh. See you soon, people. See you soon. Harris, did you get to activate the chat box? Thank you, Manuel. Yeah, go ahead, Zeus. What's up? It's happening, man. It's happening soon. It's happening soon. It's either this Sunday or next Sunday. I need to figure out if I'm going to be able to stand in front of the class. This fever is becoming my kryptonite. Yeah, is that okay? Does that work for you? I'm assuming that says busy. Okay, awesome. Both 1 hour each one. Thank you, Tarek. We'll catch you in the next one. Thank you, Rahel. Yes. You know. Sometimes there's a bias. Some people are really good at calculator and not good at non-calc. So I'm gonna give you two papers. I'm gonna give you a paper 1 and either a paper 2 or 3. Awesome. 95%. I'm still recording. I need to chop this up.